okay? When you read the question, you have to read carefully. And if there is a magic word like this, okay, so get that magic word, all right? So right here, here's or. Okay, so let's see. Roll a die. It has a six-sided. So we have 1, 2, 3, 4, 5, and 6. It's six-sided. How many odds? So 1, 3, 5. Those are odds. Okay. So we have a 3 over 6 total, number over total, number less than 3. There are 1, 2, 2 over 6 minus a number less than 3. At the same time, it is odd number. There's only 1 because it's 1 is the only one out of 6. So you combine this together. It's a 4 over 6, or we write it 2/3. Straightforward problem, but you have to think about it, and you should know the meaning of this, okay? Or event. You okay with that? Okay. Let's move to the next one, number 2. How many ways can committee of 5 can be selected from 10 members? So now here, how many ways? How many ways? How to count? How to count? So we have to think 2, repetition, repeat, or order matters. No repetition. It's because of human being. We don't pick same person twice. Order does not matter. Committee, order does not matter. Position, order matters. So based on this permutation, NPR, so we write it as there are 10 members, we choose 5. We have been done for a long time. Always larger number comes first. We have a calculator. Have 10 probability. Okay. 5. I have 30240. 30,240.
Professor, I just have one question.
Mm-hmm.
If order doesn't matter, would it be NCR?
CR, yes, thank you. NCR. Thank you. Very good. You are so good. Sorry. NCR order does. It's a no. Thank you. Patrick must study. So here you go. NC5. If order matters, then we put the permutation. Thank you for correcting me. How do I fix this? NCR 252. Thank you. Order does not matter. Combination. Yes. Peter, you okay with this?
Yeah, I'm fine. I just caught up to it.
Okay, because did you lost a link?
Yeah, no, logged on to Google Classroom. There's usually links on there, and I hit. It said updated posts, and I hit update, and it all just went away. So I was like, where do I go? So I figured I'd just email you because I was like, I couldn't find the link.
All right. Okay, that's
Yep.
good. All right, good to see you. All right, let's move to number 3. A card is drawn. Deck of 52 cards. What is a probability? Okay, so I under highlighted face card or 3. Okay, so again, here is a probability or. So I rewrite it. Probability of drawing face card or a number 3. That is probability of selecting face card plus probability selecting a 3 minus probability of selecting one card. It has both number 3 as well as a face card. All right, so it's out of 52. So no question, we have a 52 as it's a total, no problem. But let's compute how many face cards we have. How many face cards we have? Let's see. This is a page 3. I have right here, last page. I have this guy. Let's see. Okay. So we have 52 deck of cards. We consider Jack, Queen, and King. Those are face cards. So we can count how many are they. There are 12 of this. And then we also count how many threes are here. So these are threes, 4 suits. And these are face cards right here. There is no one card. It has both face card as well as number 3, just in case that you see. Okay, so this is a deck of cards. Okay, let's go number 3 right here. So go back to this question. How many face cards? We have 12 face cards. How many threes? We have 4. There's none of cards. It has both face cards as well as 3. So it is a 16 over 52. We want to make reduced fraction. Reduced fraction. How do we make reduced fraction? You look at the ending digit here. Here's a 6, here's a 2. Both are even numbers. So we just divide it. Or maybe you can use calculator and see how it works. Let's see, 16 over 52. We put the second probability. So fraction to decimal. So 413, you can do it that way. It's cheating, but easier. All right. So far, so good. Any question? No question. So let's look at the last one. Again, it's a deck of cards. So one card, okay, is selected. So a card is selected, okay. Find the probability of the card is greater than 3 and less than 8. Okay, you see that? Greater than 3 and less than 8. So greater than 3, less than 8, 4, 5, 6, 7. These are numbers greater than 3, less than 7. How many are they? There are 4. It has a 4 suits. There are 16 of it. So probability and number is greater than 3, less than 8, which is 16 over 52. Okay, different reasoning. It does have a 413. It has the same answer, but different way of writing. Okay, could have the same answer, but different reasoning. All right, let's move to next page. There are additional 3 more questions. So each page, okay? So I give you 5 minutes for each page. You try first. Okay, so let's try number 5 together. I don't know how much you have done. Let's try. A bag contains 8 red, 2 blue, 1 green marbles. What is the probability? Okay, here is the magic word, probability. Choose. Okay, so what's important? Not blue. Okay, I'm looking for not blue. So this is a not probability. So do you understand when you do the problem, you read, okay, thoroughly, and then you highlight, I usually is underlined or highlighted the magic word so you do not forget what is asking. So we are looking for probability of a not blue, which is a how many are not blue over total. That's one way to do it. Or 1 minus probability of a blue. How many are blue? Not blue. So 8 red, 2 blue, 1 green. So 9, 8 and 1 are not blue, total of 11, right? That's one way to do it. Another way, there are 2 blues out of 11. So 1 minus of that, you do have the same answer, 9/11. So one way to do it, another way to do it, not blue, probability. So every time you have a probability, write in a fraction, how many, we have like a bunch of numbers. Okay, with this, let's move to next one. A card is drawn. Okay, so again, one card. Probability, okay, so there are mixture of a problem or and not. So let's write it, probability selecting a card that is ace, ace, or not a club. Okay, or probability of ace plus probability of not a club minus probability of both. Okay. So we need deck of cards. Okay, so 52, 52. So let's go back to deck of cards. Let's remember the question. The question says ace, not club. Okay, ace and not club. So go back to here. All right, go back to this. Okay, well, I can't see. Oh, right here. All right. We have here ace. So these are aces right here. These are aces. Okay, so ace, there are 4 suits. So we have 4 ace, not a club. So where's a club? This is a club. So these are clubs. Okay, not,
Spades.
this is spades. Where's a club? This is
Above
club.
that.
Above. This is club. Okay, this is spade. Okay, club. Right here. Thanks, Peter. So there are 39 not club. And then what is ace? Not club. Ace, not club. So these are ace, not club. Okay, so these are ace, not club. All right, so keep in mind, those are card. Where am I? Okay. Ace. We have 4 aces. How many are not club? 39. How many are ace but not club? 3. So we have 40 over 52. There are 10, 13. Okay. Reduce fraction.
Can I ask a question?
Sure, yes.
So I see where you got the 4 and the 39, but the -3, if it's supposed to be a club and an ace, wouldn't it just be 1?
It's supposed to be both means club, not, excuse me, ace, not club. Here is event 1, here's event 2. So it has to be both of this event. So ace, not club. You know what I mean?
Okay.
So if it's ace or club, then we only have 1 case, but it's ace but not club. There are 3 ace but not club. So
Okay.
here, both.
Thank you.
Mhm. Okay, so are we okay with this? Let's move to next one, problem 7. Okay, probability, okay. What is this question? This is probability is given. We are looking for odds against. We are looking for odds against. So this is first time we see odds. So odds against today, odds against means are not, okay, number of not happening to number of events, right? So for this case, the event is earthquake. Okay, to get the earthquake, we have 0.01. Not to get an earthquake, it's out of 1, it's out of 100%, right? It's out of 100%. So you think this is 0.01, this is a 1 over 100, agreed? You write it into fraction, 1 out of 100 case. So if it is a 1 case happened, then we have a 99 case not happened. So it's a 99 to 1. Remember, odds we write it into ratio. Fraction, we write it into the probability, we write it into fraction. Okay. 99 to 1. Any question on these three examples? Okay, let's move to next. Okay, again, there are three questions. I give you some times. Let's do it. Okay. Okay, so let's go over 8, 9, and 10. All right, so let's read the question. So a lottery game has numbered balls 0 to 9. What is the probability of selecting even number balls or a 5? You see that? Or. So probability of selecting even number ball or a 5. That is, you see that magic word or, probability of selecting even number plus probability selecting a 5 minus probability of selecting both. Like that. So 0 through 9, let's write it out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so what are even numbers? So even number, when you divide the number, okay, we don't have remainder. So 0 is even number, 2 is even number, 4 is even number, 6 and 8. So 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. There are 5 of that. Okay, so 5 out of 10 plus, here's a 1, 5 out of 10 minus probability of both. Is there even number as well as number 5? There's none. So this is a 6 over 10 or 3/5. Okay, let's try next one. Okay, so senior citizens. It has 40% take blood pressure medicine, lowering medicine, 47% cholesterol lowering medicine, 13% both. What is the probability? Okay, selecting either blood pressure lowering or cholesterol lowering medicine. So probability of blood pressure lowering or cholesterol lowering. Or probability of blood pressure minus probability of taking cholesterol medicine minus probability of taking both. Okay, again, this is or exercise. Blood pressure, 40%. Cholesterol, plus 47%, and 13% take both. 74% take one or another. Oh, am I doing correct? Okay. Fix me if I make a mistake.
So if they're written like that, percent wise,
Yeah,
already,
sure.
you don't have to, you can just write it out as percent.
If you want to write it into, oh, okay, it's a percent, 40%, you want to write it, it's a 40 over 100, 47 over 100, minus 13 over 100. You can do that too.
Right,
Add the 74 over 100, but this is really 74%. A percent is the same as the decimal. So you remember decimal can be converted to percent, percent can be decimal to percent. So
right,
you have to
right.
worry about the convert.
I just didn't know if you had converted to a fraction or you could just leave it as a percent.
do that.
That's what I had, and then I just said, wait, am I supposed to write 100 under it, or?
This is as it is a percent. This is fine. Percent.
Okay.
Yes. Or you write it as a previous one. You can write it as a 60%, but we never bother to convert as it's a percent or write that into, or this is 0.06, 0.60. You write it into decimal. We never bothered, but that's what it is.
Okay.
All right, let's look at the very bottom of this, number 10. Family has 5 children, so many children. The probability having a girl is half. What is the probability having 2 girls followed by 3 boys? Okay, so big family here, big family here. 2 girls followed by 3 boys. So their family has a girl, first girl, second girl, girl, boy, boy, and boy. So they have 5 children. What is the probability of having 2 girls followed by 3 boys? Okay, let's see. 2 girls followed by 3 boys. All right, let's see. 5 children. Okay, so this is the one way you can do. How many ways can you get a girl? So here is I make it 1, 2, 3, 4, 5. Children number 1, children number 2, children number 3, children number 4, children number 5. How many ways can you choose a first child? It assumed there is no twins or triplets and things like that. They're boy or girl, so 2 ways. Children number 2, either boy or girl, so you have 2 ways. Children number 3, you have boy or girl, 2 ways. So everybody is 2 ways. Fundamental counting principle, we multiply all this. So there are 32 total ways. Agree? There are 32 total ways. Then we said, is there a particular way you can find the girl, boy, boy, boy? So you write it into probability. That's one way to do it. So it is a one way, 1 out of 32 is the probability. This is one way to do it. It's hard to think. Instead, problems like this is similar to flip a coin. When you flip a coin, it has either head or tail. When you have a child, it has either boy or girl. You understand this? So same thing, we are making tree diagram. So here you go. So first one, we have a boy or girl, first child, and then we expand boy or girl, boy or girl. So we have 2 children. We expand. So why I put 5 children? Because I'm one of those 5s. I'm number 2. So here is a boy, girl. Here's a boy, girl. Here's a boy, BG, and then BG. So we have 3 children, 5 children. So we go for 2 more branches. You know what I mean? So right here, BG. Right here, BG. Right here, BG. So BG, 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 and BG. Okay, so 4 children we already have allocation. But we understand we are looking for girl, girl, boy, boy, boy. Okay, so I want to circle where is girl. Start at girl. Now I branch to the girl. Then I branch to the boy. And then I branch to the boy. And then I will branch to the boy again. So that's my last child. Not my child, my children. And that's this example. Do you understand this? So when you expand one more, as you see the first child, we have 2 cases. Okay, then you have a second, we have a 4. So you have 2 children, we have out of 4. You have 3 children, let's count, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 children, 8 choices. We have 4 children right here. So let's count, how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 of this. In fact, next one is 32. Why? It's because each one is branching out 2. So multiply by 2. So 2, you multiply by 2, 2 multiply by 2, 2 multiply by 2. So it's a total of 32. So total of 32. And how many are 2 girls followed by 3 boys? That's only one branch, 2 girls followed by 3 boys. So it is also 1 out of 32. So that's another way to do it. So if you use fundamental counting principle to find that, and also find this particular case, that's okay to write it out as 1 over 32. If you forget about this fundamental counting principle, I've totally lost, no problem. We can make a tree diagram like we did, flip a coin, head and tail, and then you branch it out. It's the same answer. Are we okay with this? Boy and girls. Okay, so let's move to the next one. So for this example, it's a 1 question and then it has 4 parts. So it's not really 4 different questions. It has backup marbles and then 4 different things. Okay, so good exercise here. Go ahead and try. Okay, so let's do this together. So we pick 2 marbles. If it's pick one card, okay, or 1 marble, we don't have to worry about the repetition order matters. But if you pick 2 or more, then we have to think about the repetition and order matters. So we pick two marbles. It has a 3 white, 2 greens, 2 red, and 1 blue. Total possible ways to choose 2 marbles without replacement. Okay, so here is a no repetition. Now the question is, how about the order? Does order matter which one you pick first?
No.
No, we pick 2 marbles, like we pick 2 cards, okay? Order does not matter. So if it is a no, then what do we use?
Combination.
Combination, okay, combination. So there are total, it's a 3 plus 2, so total, that is a 3 whites, 2 greens, 2 red, and 1 blue. So it is 5, 6, 7, 8. It's a total 8. We pick 2. There's 2 marbles to choose. 8 combination 3, 2, 28. There are total 28 ways to choose. There are total 28 ways to choose. Okay, how many ways? You see that? How many ways? Choose 2 white marbles. How many whites we have? How many we choose? So there are 3 ways to choose, right? Probability, choose both are white. So probability of 2 whites, that is number of ways to choose 2 whites over total. Okay, 3 over 28. Because this is the number of ways, choose white, that's total ways. So I just replace part A and B. So here is a part B, and here's a part A. Okay, continuation. Are we okay with this? All right, the second marble is white, given the first marble is blue. All right, the second marble is white. Here is given, the first one is blue. So given condition. So the probability of a white given blue, this is a number of ways to choose both over given. Okay, both over given. So we pick 2, but the given is I want to pick the blue first. I want to pick the blue first. But how many blues we have? We have a 1 marble that's blue. Do you understand this? 1 marble that's blue. So I put blue on the side. Remember, no repetition. I put the blue on the side. So the given is I have 7 marbles left. Or put this way. So some of you say, oh, all of a sudden, why we just do this? Okay, 7 combination 1, which is a 7. Because we choose 1. Do you understand this? Because we pick 1, blue is on the side, and then we have the remaining marbles we pick, okay? So we want to pick white. How many whites are left? Still 3. How many we choose? 1, so it's a 3. Okay, given. Okay, so there's 1 blue, so I put it on the side, blue, and then remaining, I want to pick white. All right. given. Okay, so let's move to the next page, which is the last page of this probability exercise. Again, I want you to try, and let's see how much you can do. Okay, so let's do this together. Number 12. How many different, okay, so it's how many different 3-digit numbers can be used with the set 3, 4, 5, 6, 7 without replacing. Okay, so no repetition. Okay, now the next question is, we understand it's no repetition. Does order matters? You're looking at 3-digit number. Does order matter? So let me give you an example. I have 3-digit, 345, 345. I also have a same 3 digits, 534. Are they same number? They're not. Order matters. So no repetition, order matters. What do we use? Permutation. Okay, we use permutation. Okay, if it's a no, we use combination. If it is order matters, we use a permutation. So there are 5 numbers in the set. How many we pick? 3. Excuse me, it's a permutation. So permutation, pick 5, 3. So 5, permutation 3, we have 60 ways. This is one way to do it. In permutation, it's because we are taking 3-digit number, 1, 2, 3, 3-digit number, we put the bar. How many ways can you pick the first 5 ways? There's no repetition. We pick one number, so it has less than one number, 4. The next one, we have less than one number, so we multiply this together. This is also 60. Okay, this is also 60. So one way, another way. But we check those no repetition, order matters. Okay, so if it's order, then we put the bars. Okay. Number 13, immunology. We want to find the distinct ways. So this is permutation. It's a factorial with the duplicate items, right? It's a factorial. This is a question of a factorial. So question of factorial. So how do we do? It's a total number letters factorial divided by repeated letters factorials, repeated letters factorials. Okay, so that's the idea of doing this, maybe more. All right, immunology. What's the total letters? Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters. So 10 factorial over, is there repeated letters? Yes, we have 2 M's. Okay, 2 O's. I think that's it, right? 2M and 2O. 2 factorial, 2 factorial. If you immediately put this into a calculator, your answer might not be true. Don't forget the parentheses. Don't forget the parentheses, okay? So parentheses is required here. So if you use that, 10 factorial over 2 factorial, 2 factorial. So you have a calculator, go ahead and do it. So we have a 10 factorial over parentheses, 2 factorial, 2 factorial, close parentheses. All right, so I have do we have the same number? Okay. Next thing is fill in this blank. We had a little bit of exercise from previous section that we had. So I just want to turn this number 14. Let me see, when do we have this? Here. Okay, I think it's a previous page. Okay, so let's see how do we do with this problem here. I want to make it big. Just for the tables here, so we can practice in here. So we understand it better. Okay, so here you go. So we want to fill the blank odd and probability right here. So let's see what it means. So probability of event is given. Can you find probability against means not, okay? So probability, odds in favor, odds against. So on top of this, I want to point it out something so we all understand of those formulas. So probability of event, that is number of event over total. Probability of a not event, that is the number of not event over total, or you said 1 minus probability of event. I mean, that's on one way, another way. Odds in favor. Okay, of event R, number of event 2, number of not event. Odds against, number of not event 2, number of event. Okay, so these are 4 cases. These are 4 cases. So based on this, okay, I want to fill out the first 4. Then let's let you practice this. So what if probability of event is given? Are you able to find the probability of a not event? So you can write it into odds in favor, also odds against. What if odds in favor is given? Are you able to find the remaining 3 spots? What if odds against is given? Are you able to find the remaining 3 spots? Same thing, probability not, can you apply the other 3? So it could be a good exercise of practicing these guys. Okay, so let's try some of this and see how much you understand. Let's first look at this one. Probability of the event is given. Okay, can you find the probability not? So we are looking for this guy, probability not. So total event, as you see, denominator, total event is 12. 7 is the event. So how many are not? 5 are not. So 12 minus 7, 5 are not. 5 over 12. Probability of event, probability of a not event. Numerator, number of events. Numerator, number of not event. Odds in favor, event to not event. Event to not event. So 7 to 5. Odds against, not to original. So not event to event. So you flip that. That is the first thing you can do. All right, let's do another one. This time, odds in favor, that's given. Odds in favor, that's given. Can you find odds against? Probability, probability not. Okay, so let's see. Odds in favor, so this is event to not event, okay? Don't forget that. Odds in favor, event to not event. So odds against, 9 to 5, not to event. Okay, go back to probability of event. Event over total. Well, what's total? Total is not given, but total is sum of this, right? Total is sum of this. You want to write it? Total means E and not E. So total 4 plus 9, which is 13. Okay, not event over total, which is 13. Okay, do you see the pattern of this? Still not yet. Let me do one more and I want you to try. 22 to 13, not event to event. So event to not event. So flip that. Event over total. Not event over total. We still need to find the total. So total is sum of these two numbers. So 13 plus 22, which is 35. Okay, probability not, this is given. So we write it not event over total. That's what it means, not event over total. So what's the event? So E over total. Total is 11, 9 is not. So how many are? 2. So event to not event to event, odds against. All right, so I give you a couple more minutes. Try this. All right, try this. Okay, same thing. Numbers are different. Pattern is the same. In fact, you're looking at these guys, okay? Are we done? All right, so let's do it together. So first row here, this guy. So probability of an event is given. We need to find the probability of a not event. Let's see. Okay, Tyler, do you have a probability not event? I want to find the cell here.
That would be 2/7.
2/7. Tyler, can you continue for odds in favor? Right here. Tyler?
Can you hear me?
No, I don't. Did you say something?
Yeah.
Hello?
Hello?
I hear you now. What did
Oh,
you?
okay. I think my internet's been cutting out a little bit. I
Yeah.
Yeah,
apologize.
mine's too. I'm probably about.
Yeah, I think it's windy, so I see students are in and out today. So many of us.
So 5 to 2,
5 to 2, and then what's the last one?
2 to 5.
2 to 5. Very good, excellent. All right. Okay, let's move to the next row. Odds in favor, that's given. So we need to find odds against as well as probability. Okay, so let's first find odds against. Okay, let's see who has a good connection today because you guys are keep on moving. I can't see it. Patrick, Pat, can you do it?
I think it might be an issue with the Zoom because mine's doing it as well.
You
But
do
I got 3 to 8.
3 to 8. Okay, let's do it in a hurry. Do you have odds in favor? Excuse me, the probability
8 over 11.
8 over 11, not probability
3 over 11.
3 over 11. Very good, excellent. Let's move to Patrick Gallant. Odds against is given. Can you give odds in favor?
Would be 14 to 25.
14 to 25, okay. Probability of event, probability of a not event.
I have 14 over 39, probability 4, and 25 over 39 for probability against.
Thanks, Peter. All right, is that what Patrick says? Patrick, okay, so can't hear you. All right, the next one, probability not is given. We're looking for probability as well as the odds in favor and odds against. Ed, can you say something? I can't hear you. Okay, Jake, you're in and out. You're out too.
Yeah, mine's acting up a little bit too.
Yeah, but can you say something because you're already connecting?
Yep, you want me to answer the problem or?
Yes, go ahead.
Sorry, hold on, I'm just trying to. So would it be? Would it be 9 to 12 or 12 to 9?
21, okay, total.
Oh, yep.
All right, odds in favor,
And then 9 to 21.
event to not event. Okay.
Oh, I see.
Against,
And then this one's going to be 12 to 9.
12 to 9, very good, that's how you do. Okay, so total is in the denominator, but event to not event. All right. Okay. Any question?